Hey guys, I hope all of you are doing great. So in this video we will take the same example which we were dealing from our last two video, and we will try to simulate it using ADS, and we will verify that we are getting the same result as we have got from Serenade. So these are the task list from below. We will try to draw gain circle in ADS, then select gammas, then input and output matching, then verify result, and then one interesting thing, we'll try to prove that every point on a circle which result infinitely many gammas will give us the same constant gain. So let's start. This was the question we have been given, and we have already done this manual thing, but as I have said to you that in ADS we don't need to do this manual calculation. Everything is automated in ADS, but it's always good to do it manually in your Smith chart once when you are learning it, and then after you have learned it, to save your time you can use ADS. So today we will use ADS. These are the calculation we have done in our last. These are the thing, and we also know how to eliminate lambda, or from L1 how to get E. It is just 2.046 into 360, and I have already explained why it is into 360. If you are getting confused, then please revisit my last video. Okay, so let's do one thing. Let us open our ADS. So this is the schematic window of our ADS. It looks similar to Serenade, but it is a powerful software. So I am assuming you are in this schematic page in your ADS. So what we do first, as in Serenade, we know we need to have some box where we can feed our S2P file. And by S2P file, what I mean this thing. I want to feed these values of S parameter. So for that, what I'll do, I'll search here SNP, and if you are not seeing this window, then what you can do, you can just in any empty space right click, and then you can see parse. So you click on parse and you can start seeing this window. So what we'll do, we'll search SNP and we'll bring it here. Now double click it, and we want to give the file direction, like where our file is stored. So I have put in my file on Rajdeep FET. Yeah. So I have selected my file format is touchstone, and I have 2 port here. And additionally, what we can do here, which we can't do in Serenade, is that we can check our S parameter. So if you click on check S parameter, then it will open a window, and you can see this is our S21. Green color one is our S21, and it is shown on DB. It is by default they will show it on with DB. And if you just remember, or let me show you my file, my S2P file. My S2P file is in magnitude. is magnitude. So that means ADS, what ADS do, it automatically convert my S21, which is 4.45, and if you take 20 log 4.45, you will get the exactly same thing which we are seeing here, 12.97. So this is a good thing to quickly check is our file is okay or not. It also give us some other information, like if it is reciprocal or not, your matrix is passive or not, and it is not passive because our S21 is more than 1. So that means we are getting some gain. So it's not a passive matrix, it is a active matrix. So after doing this setup, we can click OK, and you can see we have only 1 port, but after I click OK, we'll get 2 port. After that, what we will do, we need 2 port here. In Serenade we have something square like button, but here we'll have the port in the form of resistance, because our port denote the 50 ohm resistance. Like by default it will be 50, you can change also, but as in the question it is said we need to design it for 50 ohm system, so we don't need to change anything. So for that, what you need to do, you just click here and find out your simulation as parameter. So you click here and you can find out this term G and term. Term and term G are same. Term G means it have a ground already attached to it, and term don't have a ground attached to it, you need to do it manually. So we will take term G for easy, because see, one ground is already attached here, so I need two port, so I have attached here. Now if you remember, we need to design our input matching circuit and output matching circuit, and here is the power of ADS, because we can do it automatically without even touching the Smith chart. So what you need to do, you come here again and you search Smith chart matching. You click here and we get it. Okay, and you place it here and then connect your wire. So after this, what you need to do, you need to click on tools and go to Smith chart, and it will say you for some update, so you update it, because it will update that from the schematic, and you will get two smart components. Smart component means this component, these components are called smart components. So we have two smart components for Smith chart, so that's why it is showing two here. So for input matching part, one is for input matching part and second one is for output matching part. So from drop down menu we will select match one, and then what we need to do, if you remember, we need to draw, like we need to first decide on gamma S and gamma in, and for that we need to draw our constant gain circle. Perfect. And constant gain circle means source circle and the load circle, and we already know how to do it manually and how to draw them in our Smith chart, but here you can automatically draw them without the need of compass or anything. So for that you need to do what? Go to view as parameter and feed your S parameter. Actually I have already type those values which we are getting from our question. Our question is here, these values I have already typed them here, and I will click done. Then what I can do in the circle, see we have two type of circle, unilateral and bilateral, and bilateral we still haven't taken, and we are designing it for unilateral. And why unilateral? Because our S12 is 0. If our S21 is not 0, like 0.21 for example, done, then in the circle you can see it will show this device is not unilateral. So that means if our device is unilateral, then only we can use constant gain circle, and if it is not, then we will use bilateral, like our operating power gain and available power gain. So those things don't take headache now, we will learn them after some time, okay, like in next videos. So in unilateral, GS is for source side. So as I am designing for input part, so I'll click here, and you can also remember that in my last to last video I have calculated the GS max, and then I have said like in dB it could go up to 3.31, and here you see G max they have automatically calculated, and they are saying it is up to 3.306, so it is close enough. And in my last to last video we have selected, like for 14 dB we have decided that our GS should be 0.835, so I have just typed it here, like you can just type it here 835 and it will come here. You can move it also, and you can just observe here how your circle can become small and big. Okay, so let us fix it to 835. And why I am taking the exact value? Because I want to compare my result with ADS and the serenade. That's why I am taking the exact example. So you click OK. Let me check again if I did everything correctly. unilateral GS, and it is showing, yeah, perfect. So now in our last video, if you remember, I have fixed my gamma S to a 0.15. Yeah, another thing, like you can directly click here and your gamma will get selected here. Like if I click here, wait, ZS, if I click here and see, gamma S already got selected. But as we already know our gamma S, like we have calculated in last video, you can take any point as your gamma S. But to keep the similarity between the two procedure, I am using the same gamma S. So let use the same gamma S. It is 0.15 and that has the angle. Wait, I need to select the, like which terminal, it is your source terminal or load terminal. I'll come to this later, like is it source or load, but for now let us select it as source. So it will be 0.15 and it is 166. After you typed it and you click some empty space, don't click anywhere in this white space if you can see it, because if I click anywhere in white space, this thing will get changed. So you can click on this gray area, any gray area. So after typing, if I click on any gray area, you can see it got changed. Previously it was 50, now it got changed, and it got changed means this is the corresponding ZS, and I did something wrong. It is not 0.166, it is 166, and then click on any gray area. So this is your ZS and your ZL is 50. Now one important thing and one minute mistake you might do here, so please observe it clearly. See, this is your ZS, P1 and P2, perfect. And you see one thing, this is your Smith chart, like that smart component, and the matching network I design here, it will get embedded to this smart component, and this smart component has P1 here and P2 here. So that means if P2 is here, so that means our ZL should not be 50 ohm, because our this side have a 50 ohm line, right? So that means my P1 should be 50 ohm. So what I'll do, I'll change it. I'll change my ZS to, let me copy it, and make it 50, because our source side has a 50 ohm line and our ZL is the required gamma S, which we already have found out. Now still one minor thing you need to observe, in this smart component what they do, they always consider this side as source and ZL as load. And if somebody who has not seen my last two video, they will tell that yeah, it's correct, this is source and this is load, nothing is no issue, because from here the power is got generated and it is propagating. You are correct. But if you have seen my last two video, then there I have said that I am designing it for gamma S, and my gamma S, here is my gamma S, okay, and my gamma S is due to the some power generating from here and getting reflected with the gamma S. So that means this should, like when we do matching, this should be considered as generator and this should be considered as load. And in my last video I have also said that if you consider this side as your source and as this smart component will consider, so by default what it do, it consider ZS as generator and ZL as load. And what we need to do, we need to do ZL as generator and ZS as load, but it is doing the opposite thing. And if it is doing the opposite thing, then we can correct it by changing it to gamma S conjugate. If you are getting confused, please see my fourth lecture. In my fourth lecture I have explained it clearly, like why we need to consider it as gamma S conjugate. So conjugate means we just need to change this sign to minus. So we have our ZS and ZL, and now we can start our matching here. So to help us on matching, we can also activate this admittance chart also. So it is activated. Blue is impedance and red is admittance chart. So this is our ZL and we need to go to 50 ohm. So that means anyhow from here I need to go to this red circle, or let me zoom it. For zooming you can click here and then you can select the space. So from here to here I need to go. That means I need the way to go from here to here, and from this part I can go directly using a stub. So to go from here to here, only way I have, if I am using the microstrip lines only, that to put a microstrip line, because if I put a microstrip line then this circle I can go this way, because when there is a microstrip line then we are moving in a constant VSWR circle, and constant VSWR circle will go around this gamma value. So what we'll do, we'll select this is your line length means this is your microstrip line. So I'll click here microstrip line, and after clicking it, if I come to this graph, it will show like automatic. I don't need to click anything, and I need to come up to here, correct? I have came here. After that I need to go here, so we can select a open short stub or a open stub. Both will do the work, but to have the similarity with our last example, I'll use a open stub. And I have said you there is no unique solution. There is many solution are there, and you can do in any way. Like you can select first stub, then microstrip line, then stub, no issue. But this is just one of the example, so don't get confused like how I know these things. I am just doing it randomly. Okay, so after that I'll select it, and from here I can reach to my destination, and I have did it. And here you can see the matching things, like matching is I'm able to do the matching or not. And if you just compare with the last solution in our serenade, our open stub was around 16.56 and we are getting it here in degree 16.38 close by, and our microstrip line was of 48.24 and we are getting around 48. So correct, we are getting it correctly. After this, what you need to do, you need to click on wheeled ADS circuits. So you click it here and that circuit will get embedded to this one. And if you want to see that circuit again, you need to click it here and you need to click on this button, push into. So if I push into, then I can see this. This is my P1, that 50 ohm is connected here, and this side my amplifier or S2P file is connected, and this is the circuit just I have manufactured or built. Okay. And if you want to go back to the previous view, you need to click the opposite. Don't click cross, it will close your ADS. Okay. So I need to here pop up. So I'm getting here. So one part is done. Now we need to design our output matching part. So again same, go to tools and Smith chart. Smith chart will get open and select the second one. So second one is got selected and we have zoomed it. So to unzoom it, this is the option. So this is unzoom, and let me close this admittance chart for now. Firstly, what we need to do, we need to see the circle for our load, constant load circle. So for that unilateral, hide the GS circle and open your load one. So see, load can go from 0 to max 0.196 dB. They are matching with our last day calculation. So what we have decided there, for 14 dB gain, we will take the maximum one. So it is a maximum GL. So now every point here will give me a gamma L, and that gamma L will result the same constant gain, 0.197 dB. and there what we have selected, you can select directly using your cursor here, but as we have already selected there in our last example, so we'll take it as 0.17. okay, I need to select, so it is my source part. For now I am coming to this confusing topic again, which is source or which is, and you know, in load part we don't have any confusion actually, in input part only we have the confusion. So our gamma L would be in the source part, because see my cursor, from here I can see the gamma L, correct? From here I can see the gamma L, and I am seeing gamma L because some signal getting generated from this end. So that means this is my generator and this is my load, and from outside wall this is the same thing, this is my load and this is the generator. So in the output part we don't have any confusion. So let us select our ZS, which we have already calculated in our lecture 4, and it was 80 degree. And our ZL will be 50 only. So again we can select, like, let me enable this chart, admittance 1, and let me zoom it, and let me close that circle also, hide. Okay, now what we need to do, we need to go from here to here. There is a path in black or blue chart, but blue chart is a impedance chart, and in parallel stub matching we don't use the impedant one. So that means red is our way only. So that means anyhow I need to reach to this red line or circle, and then I can come to here. So to keep the similarity between our last video, like that matching part, what I'll do, I'll first select this open stub, I'll come to here, and then I'll select that microstrip line, and see microstrip line is not reaching, so we can edit it, no issue, both things will get edited. And after that I can reach easily here. Okay, and you can see I'm getting it is as 91.288, similar to the last we have got 90, and this one we're getting 18. In our last we got it as 19, so we are close enough. We are not exactly close enough because we need to zoom it and we need to see it. So after that what we'll do, we'll click on build ADS circuit, and it got embedded here, and if you want to see it, click it here and pop down and you can see it, and then pop up to the main circuit. So we have already done with our matching part, input and output part, and you can see how without the touching Smith chart, like paper Smith chart, we can able to do it here, and without calculation also, those big formula, those using MATLAB or calculator, nothing we need to do. So after that, how to simulate this example? To simulate your example we need a simulation controller. So we will do S parameter simulation. So for that you need to click here and select your S parameter, simulation S parameter, click here, and then you can see SP, you just bring it here. Like in our Serenade we used to bring the frequency box here, like analogous to last time, it is your bringing this S parameter, and you can give your frequency here. So you double click here and you can select your frequency range. So let us do from 0.6 to 1.5 because our point of interest is 1 gigahertz, and let's reduce the steps to this. Okay, so we are about to ready to see the result. To see the result you need to click here, this gearbox, you need to click it here, and it is simulating, and you get this window. To see the result, you need to click on this square, bring it here, and then similar to Serenade, you need to click the things which you want to see. So I want to see S11 add, and it is in DV, and I want to see S21 add, and it is in DV, and OK. And let us enable the marker, and we want to see it at 1 gigahertz. And see, at 1 gigahertz we are getting nearby, yeah, we are getting it 13.97. and if you remember, in the Serenade we were getting around 13.98, but that doesn't matter because our specification was 14 dB, so we are getting near about 14 dB only. And I know S11 is very bad here, but that thing we can do in optimization. Now we are not taking that one, now we are just focusing on getting the gain. Okay, so if you know our agenda, so our agenda was to draw this thing, verify results, so we have done with the 4th thing. Now last part is to prove that all gamma point on the circle indeed result constant gain. So let us change the gamma point, and let me keep this on, history on, like it will be here only. Now what I'll do, I'll go to tools and I'll change gamma S only one I'll show you, and I'll prove to you that indeed we are correct, that every point on our circle result the same gain. So let me on the gamma S circle. So this is your gamma S circle, and we, for 14 dB gate, our gamma S should be 0.85, so I'm not changing it. Okay, and now I will select using my cursor. I won't be typing it here directly because I don't know which point I need to select. So for that, what I will do, so we will select using a cursor, and we can see some points. Okay, and we will just write down that point in our copy. Actually there is a way to directly assign this point to ZL, but I am not going to do that because there is some confusion is there. So let's do it without any confusion. So just write down this number, it is 0.688, and our angle is 149 around. So this is our new gamma S, because I have selected it from this constant gain circle, and the value of my gamma S should be go into our ZL part with a conjugation, right? Because I have already explained why. So let me change it, 0.688, and we have got it in positive from 149, so we'll write it as minus 149. Actually there is a way to not to do this complication like I'm doing now, conjugating or something, like using these two options, but now I'm not using this thing because this is a little bit confusing right now, might be for you. So that's why I'm doing it manually using the last concept developed in lecture 4. But I think you can do this. This is not so big thing. You just need to write it there, and you need to click ZL, and you need to conjugate it and write down here your gamma point. So we have selected ZL, and our ZS is 50 ohm. Why our ZS is 50 ohm? Because, let me minimize it, because this part is my ZS P1 and this is the gamma S point. And now this is not valid, so let us delete it, and let us enable this admittance chart. So I need to go from here to here, so that means I need to go to this line. So I'll select a microstrip line, and I can go up to this line, and then a stub. Using a stub I can reach to this point. After that, build radio circuit. So it's got build, and let us check it if it is got correctly or not. And yes, it was, see, degree got changed. Previously it was 16, now it got changed. So now we'll check or verify, and we should get the same result, 13.97 or near about that, because we are doing it roughly, like exactly we are not matching it. So near about the same thing we need to get it here. And see, this was your previously, which we have taken the history on, and this blue line is now, and we are getting around 13.90. So we are getting near about the same point. So that means any gamma in that circle will result the constant gain. We are not getting exact the same thing because we did some rough work here. Like if you do it like after zooming, like if you zoom it and do more seriously, then you can see we come little more than the required point. So like if you do it very seriously, then you will get the exact same gain what you have got in the last one. Okay, so that's all for today. And if you still haven't subscribed to my channel, I don't know why you are waiting. Subscribe it now, because I'm going to bring many more videos like this. Thanks for your time. Bye bye.